Good morning, Nana. Okay, yesterday we learned some formulas, Nana. Once that on that basis, we will do some different types of problems. So yesterday these formulas we learned the number of ways of selecting. All of you, good morning, Nana. Once again we revise the formulas. Yesterday problems. Formulas. The number of ways of selecting or things from n distinct things is NCR. Okay, out of n things we are selecting or things means it is denoted by NCR. Next one, second formula is the number of ways of selecting. The number of ways of selecting or things from n identical things are there. First are taking n things and second one also similar. All are similar. How many are there? N are there. So total things is equal to we can select is equal to n one way. Only one way. All are similar. How many ways we can select means only in one way. And then next concept is total number of combinations. Total number of combination means we can select either out of n things, we can select 0 things or 1 thing or 2 things, 3 things up to so on all things out of n things. For each thing there are two possibilities. First, how many possibilities mean if you are selection or rejection. So that therefore the total number of combinations of the n distinct things are total things are n. So if the two possibilities mean selection and rejection, then the number of combinations of n distinct things is nothing but 2 to the power of how many terms are there? N terms are there. So that therefore then total number of combinations of the n distinct things is 2 power n. Okay. Next, same thing. If it is taking out of n things, we can select 0 things means it are denoted by NC0. We are out of n things, we are selecting one thing means it is denoted by NC1. It is selection of two things out of n means NC2, like this so on up to NCn. Therefore, R means we can write plus symbol, and means we can write into symbol. Okay. Then C0 plus NC1 plus NC2 plus NC3 plus NC4 up to so on up NCn. Then it is goes to the formula is 2 to the power of n. Just now we have learned that is number of combinations of n distinct things is nothing but 2 power n. So all the things can be going to collection is 2 power n. So then that implies the total number of combinations of n different things, one or more things. This term should not be there. This term we can eliminate. So that is NC0. So then it is NC0 means we can write as this as to 2 power n minus 1. 2 power n minus 1. Okay. Just only one thing is not there means up to this number of combinations of n different things taking 1 starting with 1 1 2 3 4 up to n things is denoted by 2 power n, but nc0 is not there means so keep it as to minus nc0, then we get the formula 2 power n minus 1. Okay, this is the formula for the total number of combinations taking out of n different things, taking one or more things can be represented by 2 to the power of n minus 1. Total things are at a time is nothing but 2 power n. Therefore, next formula is the total combinations of n identical things. How many we are selecting means it can be selected from out of 0 things. We can select only one way, One thing can be one way. All things can be only in the selection is one way out of n things. So therefore total number of things equal to n plus 1. 0 is included. That is why we can say that n plus 1. And then next formula, the total number of combinations of p plus q things taken any number of time when p things are alike, q things are alike, that is nothing but p plus 1 into q plus 1. P things are alike. How many types of we can select? As 0 things we can select, 1 thing we can select, 2 things, up to how many p. Therefore total number of combinations are p plus 1 things. And then next, out of q things are alike. So out of q things also we can select 0 things, 1 thing, 2 things, so on up to q things. The total number of ways equal to q plus 1. Therefore the formula is p plus 1 into q plus 1. When out of p plus q things we are taking any number of time when p things are alike and q things are alike is p plus 1 into q plus 1. This is the formula. If it is taking one or more means the 0 term is not there. So p plus 1 into q plus 1 we can write minus 1. And then p1 things, p2 things, p3 things are alike, and then also pk things are alike. Then total number of ways equal to combinations equal to p1 plus 1, p2 plus 1, p3 plus 1, so on up to how many pk things are alike. Pk plus 1 all should multiply. Taking one or more times is 0 terms are not there, so put it as minus 1 up back outside. Okay, tomorrow we'll discuss on the basis of this question. One question is in the mains level question, it is given in the examination. So that is out of three different books on economics, for three different books on economics, four different books on political science, and five different books on geography. How many collections can be made if each collection consists of, first one, exactly one book of each subject. Second bit is at least one book of each subject. This is the question. Out of three different books on economics, four different books on political science, and five different books on geography, in how many collections can be made if each collection consists of exactly one book of each subject? And second question is exactly at least one book of each subject. So very basic one. There is exactly one book of the each subject means how many ways we can do? Out of three books on economics, we are selecting only one book. This can be done in how many ways, Nana? Venkatramana, Akhilesh. Out of three different economics books, we can select exactly one book. Then it can be done in how many ways? Chinmayi, Sahiti. Out of their question is given that we are selection of the things out of three different books. Exactly one book can be selected. In how many ways? Give the response. Out of 3 books, we are selecting 1 book. So this can be done in how many ways, Nana? Anybody give the response? Rishabh, Akhilesh, Sritan is there, Chinmayi, Manvita. Out of 3 books, small question on economics. Exactly 1 book is selected. One book can be selected in how many ways? 3C1 ways. 3C1 ways. And similarly, political science, 5 books are there. 5 books on political science. Yes, 5C1 ways. And next one, no, this is 4 books are there. Then we can select is 4C1. Political science number of books are only 4 books. This can be done in 4C1. And political science after geography, 5 books of geography, that is can be done in 5C1 ways. Yes, it is geography only. 4 books of political science, 5 books of geography means 4. So total number of arrangements, this how many total number means we can select either this in. Therefore the answer is I am writing here 3C1 into 4C1 into 5C1. That is 3 into 4 into 5. Totally 60 ways. Totally 60 ways. For the question there is exactly 1 book of each subject is selected. But at least 1 book of each book is selected. At least 1 book out of these books. Just now we learned the formula, that is how many, which 2 power n, the total combination of n different books, at least 1 or more books. That is the formula 2 power n minus 1. Here also we can apply this formula only. At least 1 book of the each subject can be done in. Their question is given like this. Second bit. Out of 3 books on economics, at least one book can be selected in 2 cube minus 1 ways. Why? Because 2 power n minus 1. Next, similarly, 4 books on political science, 2 power 4 minus 1. 5 books on geography, that is 2 power 5 minus 1. Therefore, total number of books we can select at least 1 book. At least 1 book of each subject can be done in 2 power 3 minus 1 into 2 power 4 minus 1 into 2 power 5 minus 1. That is 7 into 15 into 31. 15 7 ja 105. 105 into 31. That is 55. And then 31 plus 1. That is 32. Okay, 32, 55 ways. At least 1 book can be done in the number of ways. At least 1 book out of 3 different books of each subject is 1 book of each subject is, this is the value of the question. And similarly, second question also like this only. If there are, question number 2, if there are 5 alike pens, 7 alike erasers, find the number of ways Find the number of ways can a student can a student find the number of ways of selecting. Find the number of ways of selecting. Find the number of ways of selecting any number of bracket lo one or more things out of them. There are 5 alike pens, 7 alike erasers. Find the number of ways of selecting any number of one or more things out of them. The question is given like this. How many ways? Just now we learn formula, that is P1 things are alike, Q things are alike, taken one or more things. Taken one or more things. This can be done in how many ways? P plus Q into Q plus 1 minus 1 ways. P things are alike, Q things are alike, taken one or more time, that is P plus 1 into Q plus 1 minus 1. Okay, the formula is like this. So here 5 things of 5 alike pens. 5 alike pens. This can be selected either 0 things or 1 thing or 2 things or 3 things, 4 things, 5 things. Totally we can get how many ways? 6 ways we can get. And similarly, 7 alike erasers. He can be number of ways of selecting as 0 eraser or 1 eraser or 2 eraser. So on up to maximum 6 erasers he can select. So total number of ways is equal to 7 things. In find the number of ways, one or more is asking. Therefore, one or more means subtracting this condition. That is 6 into 7, P plus 1 into Q plus 1 into 6. Okay, question number, what is the question? 24, 5. Next one is also is there. 5 alike pens, 7 alike erasers, and pencils are given. So in the question, that is why I am thinking whatever the here 6 alike pencils. 6 alike pencils also given in the question. Then we get options are not matching what the mistake I had done. I am seeing. Okay, 6 alike pencils also given. Out of six pencils, we can select as 0 pencil, 1 pencil, 2 pencils, or anyway. How many things we can select? 6 plus 1, that is equal to 7 things can be selected. Now, therefore, the number of ways of selecting any number of things, that is equal to 6 into 7 into 7 minus 1. That is 336 minus 1. That is nothing but 335. 335, how much, Nana, multiplication? How much? The answer 42 into 7 minus 1. 42, 49 into 6, 294. 294 minus 1, that is 293. Total number of ways. Okay. One or more so it can be selected as 0 things we can subtract it. So all these minus 1 we can do. 6 into 7 into 5. Okay, in the same way, next concept we will discuss now. Next concept. Write down the heading matrices. Yes, write down the heading as matrices. 2 by 2 matrices are formed by using the elements 1 and minus 1 as in the matrix. Find the number of matrices that can be formed is dash. The question is given like this. Okay, matrices. On this concept, one question will be in the examination. The question number 1 is 2 by 2 matrices are formed by using the elements 1 and minus 1. So 2 by 2 matrices are formed by using the elements 1 comma minus 1. Then find the total number of matrices that can be formed is in the second question. This is the first one. Same thing as second question. The number of matrices are in positive determinant or dash. The number of matrices are in positive determinant value r dash. Next, similarly, third question. So many questions are there. Negative, third bit. Negative determinants. Negative determinant. How many? Question number 4. Number of singular matrices. Question number 4. Number of singular matrices. Nana, first year we learn the matrices concept. On the basis of concept, there are questions like this are given in the questions. So many are there, but first question is like this. 2 by 2 matrices are formed by using the elements 1 and only minus 1. Then find the total number of matrices that can be formed is how many they are asking. Second question is the number of matrices are positive determinant value is dash, negative determinant value how many, and number of singular matrices are how many. Okay, that is the question. So for this question we have to observe, that is the first bit solution. We have to observe 2 by 2 square matrices. Let the matrix of the form, suppose A, B, C, D, that is of 2 rows and 2 columns. Let it be A, B, C, D 2 by 2 square matrix. Okay. Then how many are by using the elements 1 and minus 1? How many we can form as number of ways of matrices that can be formed is how many are they asking. Total number of matrices that can be formed is. So we can select, we can arrange as the elements for A, B, C, D. Then we can arrange A for only by using the values for A. We can apply, put it on 1 comma minus 1. That is how many ways? 2 ways. And for number of set element B, that is also we can apply 1 comma minus 1. How many ways? 2 ways. And next for the C value also we can arrange 1 comma minus 1. How many ways? 2 ways. And similarly the element for D, the number of ways equal to, we are applying either 1 or minus 1. This is also 2 ways. Therefore, the total number of values, the total number of values to form a matrix that can be order of 2 by 2 is how many ways, Nana? Totally 2 to the power of 4 ways. So this is the question for first option. How many number of matrices that can be formed as by using the elements 1, 9, minus 1. So then the total number of values are 2 to the power of 4. Okay. Then go to the first question. The number of matrices are positive determinant value is dash. The positive determinant means what is the determinant value of the matrix? What is the determinant of the matrix? Determinant value how much, Nana? So if A equal to ABCD, nothing but determinant always can be expressed as det A, that is denoted by AD minus BC. So the question is given, what the question? How many number of matrices are positive determinant value? Positive determinant they are asking. Positive determinant. Positive determinant means that should be positive determinant means what? Positive determinant means it should be the value is nothing but AD minus BC must be positive. AD minus BC must be positive. Positive determinant means. Okay. For these cases, we have to observe. By using the numbers only given in the question, 1 and minus 1 we can use. AD minus BC must be positive means. So let us we observe the condition. If AD, this implies AD must be positive means let us AB, suppose we take it as minus 1, minus of minus 1 then becomes to 2, 2 greater than to 0. So in the place of AD must be equal to how much we can guessing the values, AD must be 1 and BC must be equal to how much we want to select in the product of the value must be minus 1. So separable cases we have to write. How many cases we can get as AD equal to 1? If necessary, if AD equal to 1 means we can select as A equal to 1 and then AD equal to 1. And then next case is A equal to minus 1 and D equal to minus 1. Then totally how many cases? We can select by here 2 ways. And here BC equal to minus 1 means B should be placed value 1 and C equal to minus 1. And another way is B equal to minus 1 and C equal to how much? C equal to 1. This is total things are 2. Therefore, the number of positive determinant value, number of ways of positive determinant is how many ways? Totally 4 ways. 4 ways. This is the answer. Here AD minus BC must be positive. It can be possible either by using the given digits as 1 and minus 1, that can be AD minus BC, that is 1 minus of minus 1, that is 1 plus 2, 2 greater to 0. So that means AD must be 1, we have to select, and BC must be equal to minus 1. So AD must be 1, nothing but A equal to 1, D equal to 1. And another way, A equal to minus 1, D equal to minus 1. Then only we get AD equal to 1. And here BC equal to 1, C equal to minus 1, B equal to minus 1, C equal to 1. Therefore, total number of ways here that should be in the form positive determinant is how many ways? 4 ways. In similarly, the question is given that third question is given negative determinants. Negative determinants also is given. Negative determinants. In the same way, we can practice on this. AD minus BC must be third case, third question. Negative determinant. That means AD minus BC must be lesser to 0. AD minus BC lesser to 0 means AD must be what? Minus 1 and BC must be what? 1. So that is the how many cases we can observe. A equal to put it as the 1, D equal to minus 1. Otherwise A equal to minus 1 and then D equal to 1. Similarly BC equal to 1 nothing but don't go elsewhere. Please stay on the line all of you. So B equal to 1, C equal to 1 and then C equal to minus 1 and then D equal to minus 1. Therefore, total answer equal to the negative statement how many? Here to here to. Total ways are similarly 4 ways. For the negative determinant. For the negative determinant also 4 ways. Okay. That is the question number 3. In the similarly, the question is given that as fourth question is question number 4. Number of singular matrix. What is mean by singular? What is mean by singular? Singular means what Nana? Manvita, Rishabh, Dikshita, Vaishnavi, Ramana. Singular matrix they are asking. Then it is AD minus BC must be equal to 0. Then it is only for singular matrix. Singular matrix meaning is AD minus BC must be 0. So AD minus BC must be 0 nothing but AD must be becomes to 1 and BC must be equal to 1. Then how many cases we can observe? If A equal to 1, D equal to 1 and or else A equal to minus 1, D equal to minus 1. And here B equal to 1 or C equal to 1. And then B equal to here minus 1 or C equal to minus 1. Totally how many case? 4 ways. Or else AD must be another case also we can observe. AD equal to minus 1 and BC equal to also minus 1. AD equal to minus 1 means only we get AD equal to minus 1 means 1 into minus 1 or minus 1 into 1. That is 2 ways. BC equal to minus 1 means it should be also 2 ways. Therefore, total number of singular matrices, total number of singular matrices, totally how many? 4 plus 2 plus 2. That is 8 ways. This is the answer. This question in the last previous year question, that is the number of cases of the values, number of determinants. In the similarly second question also is there. Same method. The number of matrices containing four elements that can be formed by using the digits 1, 2, 3, 4, 5 is dash. The number of matrices containing 4 elements that can be formed by using the digits 1, 2, 3, 4, 5. How many ways we will get? They are asking. How many ways, Nana? Give the response. Mukunda, Shivadanesh, Sahiti, Akhilesh, Dikshita. In previous question, they are only asking only by using 1 and minus 1 they are asked. 19 minus 1 only they are asked. 5C1. No. How many ways we can get is, this is the positive values. If our A getting value is 4, for total number of ways are 2 power 4 we got. So here the question only by using the before the question 19 minus 1 only. But we are doing here total number of elements are 1, 2, 3, 4, 5. Okay, total number of matrices containing 4 elements that can be formed by using the digits 1, 2, 3, 4, 5. How many? So solution is, the number of matrices, it may be A, B, C, D square matrix, or else A, B, C, D, it is a rectangular matrix, or else A, B, C, D, it should be a column matrix, it is a row matrix or column matrix. So number of digits here, what, how many number of digits are given? Number of digits are given as 1, 2, 3, 4, 5. Therefore, the total number of ways of matrices containing the 4 elements that can be formed by using the given digits as, how many elements are given? 5 elements are given. Number of matrices, number of ways of forming a matrices we can, that is 3 into 5 to the power of 4. 3 into 5 to the power of 4. 4 elements only we can select, not given the square matrix cannot be formed. So 3 means it may be square or rectangular or column matrix. Total we can select the elements as 5 elements, and here a equal to, why, because A equal to 1, B equal to 1, A equal to 1, or else 2, 3 and 4 or 5. Totally how many ways? 5 ways. And similarly for B also 1, 2, 3, 4, 5. Here also how many ways? 5. C equal to 1, 2, 3, 4, 5. Then also we can get 5 ways. And for the element of D also we can apply any number. So it can be adjusted in 5 ways. Totally 5 to the power of 4 ways. We are selecting either A, B, C, D. Each number, each digit element should be formed by using the digits as 5 ways. How many number of matrices are there? 3 matrices are there. That is square or column or rectangular matrix or column matrix. Then we can write as the number of ways of matrices we can formed by 3 into 5 to the power of 4. This is the answer. That's all. Okay. Same thing as to next question is there. Find the number of 2 by 2 matrices. Question number 3. 2 by 2 matrices are formed by using the elements 1, comma 0. Question number 1 is the total number of matrices, is dash. Question number 2 is given that the number of matrices having positive determinant value. Positive determinant value is dash. Question number 3, the question is given the number of matrices having negative determinant value is dash. Question number 4. The number of singular matrices. The number of singular matrices is dash. What is the first answer, Nana? What is the first answer? How many total number of matrices? How many we can select? How many number of ways of matrices we can arrange or select? How many elements can be used as 1, 0 can be applied. So 2 by 2 matrix can be determined in the form A, B, C, D is of the form. Then for each value we can apply for each value for each and every number element as 1, 0, here also 1, 0 and here also 1, 0 and for D also 1, 0. How many ways? 2 ways. This is 2 ways and this is 2 ways. This is 2 ways. Therefore, the total number of ways equal to how many? 2 power 4, that is equal to 16. This is the total number of matrices. Total number of matrices. And similarly go to the number of matrices the having positive determinant. Positive determinant only they are asking. So for the second question, the matrix is of the form A, B, C, D. Positive determinant is det A equal to this is det A equal to, we can write AD minus BC. Therefore, AD minus BC must be positive, means by using the elements is given that 1, 0. Now it should be positive, means AD must be 1 and BC must be equal to 0. Then only the cases will be we can get. AD must be 1 means by using these elements, if A equal to 1, D equal to 1 only, then AD becomes to 1. And that is BC is equal to 0 means if it is BC, B equal to 1 and C equal to 0. And next, if we get B equal to 0, C equal to 1, another case. And else B equal to 0 and then C equal to 0. Total number of cases here 3 ways, here and here only 1 way. Therefore, the total number of ways equal to 1 into 3, that is 3 ways. These subcases we have to multiply. Total number means we can add. And then go to the third. AD must be positive determinant. That is positive determinant value. Total number of ways equal to 3 ways. Now here third bit, negative determinant. That means AD minus BC must be lesser to 1. This can be done in either AD equal to 0 or else BC equal to how much, Nana? BC equal to how much? BC equal to 1 only, they will get the negative value. AD equal to 0, nothing but how many cases? 0 cases we are just now we have completed. That is 3 ways. Then we get, if it is A equal to 1, D equal to 0, or A equal to 0, D equal to 1, or else A equal to 0, D equal to 0. And then BC equal to 1 means by using the elements only in one way. If it is B equal to 1 and C equal to 1. So therefore total number of ways equal to 3 ways. That is to be negative determinant. Total number of ways of total number of ways equal to 3 ways. Next question number 4 is given. Question number 4. Question number 4, that is singular. Singular matrix nothing but AD minus BC must be equal to 0. That means AD equal to BC. AD equal to BC means how many cases we can get? AD must be equal to BC. In how many ways? If it is subcases, we can write if AD equal to 1, nothing but we put it as A equal to 1, D equal to 1. Then how many cases we can get? Only one way. And then BC equal to 1, nothing but here also B equal to 1 or C equal to 1. This is also only in one way. And otherwise AD equal to 0 or BC equal to 0. Then only AD equal to BC. If AD equal to 0 means how many cases we can get? 3 ways. Just now we written. And BC equal to 0 nothing but we can get as 3 ways. So totally how many ways? The sub case is nothing but we have to multiply. Therefore, total number of ways 3 into 3. 3 into 3 nothing but 9. And here this is the first case. 9 in 9 in 9 plus 1. This is the another case. Case 1 and this is case 2. 9 plus 1, that is total. 1 into 1 plus 1 into 1. 9 plus 1, that is total 10 ways. Therefore, number of singular matrices equal to 10. Or else we can check it by shortcut only. Whatever the shortcut here, singular matrix means total minus, what is the shortcut? In the second way also we can do like this. Second method. Number of singular means total arrangements minus of positive determinants plus negative determinants. So total means 16 we got. Positive means we can get 3. Negative means we can get 3. So 16 minus 6, that is also 10. Or like this also we can do. Okay, total minus positive plus negative, then we get the singular matrices. This is the second question. Okay, remaining third question. Question number 3. 2 by 2 matrices are formed by using the digits 1, 0, minus 1 is given in the question. 1, 0, minus 1. 1, 0, minus 1. 3 elements are given. 1, 0, minus 1. 2 by 2 matrices are formed by using the digits 1, 0, minus 1. First question, all are same. Total number of matrices is formed is dash. Next, second question, having positive determinant, positive det, how many are there? Question number 3, negative determinant, how many are there? Question number 4, number of invertible matrices. Number of invertible matrices is dash. Number of invertible matrices, how many are there? They are asking. Okay. Solution. For the matrix ABCD, that is to write as 2 by 2 matrix. 2 by 2 matrix means we can using the digits are 1, 0, minus 1. Therefore, the first place can be filled in how many ways, Nana? For A, we can get how many ways? A 1, 0, minus 1, that is 3 ways. And for B also we can arrange the first second place can be filled in either 3 ways. Either 3 condition also 1, 0, minus 1. So that is also 3 ways. And for D also 3 ways. So therefore total number of arrangements, that is total equal to how many ways we can get? 3 power 4, that is 81 ways we can get for the first question. This is for the first one. In similarly second one. Second one means the number of positive determinant values. Second one, the positive determinant value. That means AD minus BC must be positive. AD minus BC must be positive means the subcases we can do. AD equal to 1, either BC equal to 0, or else another way we can get how AD equal to 1 and BC equal to minus 1. And here either AD equal to 0 or BC equal to minus 1. So these are the possible cases. In these possible cases, if AD equal to 1, then we can write as this. AD equal to 1 means A equal to 1, either D equal to 1, or A equal to minus 1, either D equal to minus 1. So these are two ways. Next goes to BC equal to 0. This is the value for AD equal to 1. Now we have to write as BC equal to 0. BC equal to 0, nothing but how many cases we can get? Either B equal to 0 or C equal to 0. Or else B equal to 0 and then C equal to 1. Or else B equal to 1 or C equal to 0. Or else we are applying elements as 1, minus 1, 0 are there. Okay, B equal to 1 is over, C equal 0 is over. Next B equal to, let it be minus 1, C equal to 0. And B equal to 0 or else C equal to minus 1. Total number of A's equal to how many? 1, 2, 3, 4, 5. 5 A's. Therefore, if AD equal to, for the first case is over, if AD equal to, AD equal to 1, BC equal to 0, then total value here 2 into 5. 2 into 5. That is how many cases? 10 ways we will get. For the value for AD equal to 1, BC equal to 0. Next case, cases should be right down. That is the question. AD equal to second case, case 2. AD equal to 0, BC equal to what? AD equal to 0, BC equal to minus 1. Or else AD equal to 1, BC equal to minus 1. AD equal to second case, AD equal to 1 and BC equal to minus 1. AD equal to 1 nothing but if it is AD equal to 1 nothing, A equal to 1 or else D equal to 1. Or else A equal to minus 1 or D equal to minus 1. So therefore how many cases? 2 ways. 2 ways we will get. And BC equal to minus 1 means B equal to 1, C equal to minus 1. Or B equal to minus 1 and then C equal to 1. Here also we can get 2 ways. Therefore, case 2 total is 2 into 2. That is 4 ways. This is the for the case 2. And then go to the case 3. Case 3 is what? AD equal to how much? AD equal to 0 or BC equal to minus 1. AD equal to 0 or BC equal to minus 1. AD equal to 0 means just now we have learned that is 5 ways. BC equal to minus 1 means either 2 ways. Therefore, total number of ways here 5 into 2, then we can get 10 ways. Therefore, having positive determinant values by using the 3 cases, that is totally 10 plus 4 plus how much Nana? 10 plus 4 plus 10. That is equal to 24 cases. This is the case 2. And third question. Question number 3 is given. Question number 3 nothing but AD minus negative determinant. Negative determinant, that is AD minus BC is lesser to 0. These cases nothing but the possible cases are AD equal to 0 or BC equal to how much? 1. Then 0 minus 1 lesser to 0. Okay, fine. Next, or else AD equal to minus 1 and BC equal to 0. Or else AD equal to minus 1, then BC equal to 1. So from these cases, AD equal to 0, just now we have completed. AD 0 means how many cases we got? Generally 5. If it is BC equal to 1 means we can get only if A equal to B equal to 1, C equal to 1, or equal to B, A equal to minus 1 and D equal to minus 1. So 5 into 2 cases, that is totally 10 cases we can get. And for this AD equal to minus 1 means just now we have completed, 2 ways will come. 2 into BC equal to 0 means 5, that is 10 ways. And then AD equal to minus 1, BC equal to 1 means AD equal to minus 1, we get minus 1 means 2 ways. Either A equal to 1, D equal to minus 1, or A equal to minus 1, D equal to 1. That is why you can write 2. And BC equal to 1, nothing but similarly 2 ways. So total number of cases is nothing but 24 cases, 24 ways. Therefore, negative determinant value, we have 24 ways. You can get 24 ways. And then fourth bit is there. Fourth bit, question number 4. That is AD minus BC must be equal to 0. Invertible matrices or singular matrices. Singular matrices means for singular matrices. For singular matrices. So then it is AD equal to 1 and BC equal to 1. If it is AD equal to minus 1 and then BC equal to minus 1. Or else negative, another case, if it is AD equal to 0 or BC equal to 0. So these are the 3 cases. First case, AD equal to 1 means how many cases? Just now we have completed, that is 2 cases. BC1 also equal to 4. And then AD equal to minus 1, just now we completed. Minus 1 is how many cases? We got 2 cases. BC equal to also 2 cases. And then AD equal to 0 means 0 terms is 5. BC means 5. Totally 25. Then we get as 33 ways. Total 33 ways we can get. In the question number 5, last bit. Question number 5. Number of invertible matrices. Number of invertible matrices means that determinant should not be 0. Either it can be negative or positive. Okay. Invertible means it should be negative or positive and determinant should not be equal to 0. So write that. Means that you also write. Means that invertible matrix definition. Determinant should not be equal to 0. Either can be negative or positive. Then it is said to be invertible. So we got negative means 24. How many we got? Negative it's 24. And then positive also 24. Therefore 24 plus 24. Then we get 48 number of invertible matrices we can get. This is the basic formula, then only we get the answer. It means that determinant should not be 0, either can be positive determinant or negative determinant. Then only it possible by number of invertible matrices. So totally we have negative means 24 we got and positive means also 24. Total number of that is 48 ways we got. Okay, then go to the next concept, that is question number 5. Question number 4. For matrices, so 2 bits are remaining, Nana. 3 by 3. Let us start with 3 by 3. 2 by 2 matrices are over. Then 3 by 3 matrices. 3 by 3 matrices are formed by using the elements 1 comma minus 1. Then first question, possible determinant values are dash. Just only given as the possible determinant values of the 3 by 2 matrix by using the Elements 100 minus 1. What are the possible determinant values? Let 3 by 3 matrix nothing but we have to assume A1, B1, C1, A2, B2, C2, and then A3, B3, C3. This is order of the matrix 3 by 3. Okay. So determinant they are asking. So therefore determinant of A nothing but A1 into first row, first column, and then go to the determinant of the submatrix B2 C3 minus B3 C2 minus second column plus minus plus minus B1 into for our convenience you can take as to better to write A2. A2 will take A2 will take A2 this column this row will be cancelled, then B1 C3 minus B3 C1. Next A3 of this column and this row will be closed, then B1 C2 minus B2 C1. Okay, our convenience we have to multiply A1 B2 C3 positive values I am taking here minus into minus plus A2 B3 C1. This is the value for this positive values I am taking A2 B3 C1, and next positive value A3 B1 C2. A3 B1 C2 minus over, I am taking minus common from this first term, then it is goes to A1 B3 C2 and then A2 B1 C3 and then A3 B2 C1. Okay, this is in the form of product of the values. This is always positive and this is the always negative. Total value becomes 2. Total value this is goes to A1 A2 A1 A2 A3 B1 B2 B3 product, and then C1 C2 C3 whole square will get in the form of A plus B plus C minus of formula, that is A plus B plus A1 basic formula. This total becomes 2. Whole square means always it should be positive. Therefore, we have to write as possible cases first by using the digits. Possibilities we can write. Possibilities are by using the elements. What are the given elements are given? Only 1 comma minus 1. 1 comma minus 1 is given. So positive means by cases A1, A2, A3, B1, B2, B3, C1, C2, C3. So by getting the all are 1 we have to take, we get only the positive. Why? Because A1, A2, A3, B1, B2, B3, C1, C2, B3, C1, C2, C3 whole square. Whole square means it should be always positive. So possibilities we can write. All 4 ones we have to take. 4 ones. One is once we can apply, and 4 ways as to minus ones, and then 2 can be applied as by using the minus ones we can get 2, and 2's we can get 1's. So total possibility determinant should be 0 also. We can write 4 minus 4 comma 0, and then 4 minus 4 comma 0, and another case is all are minus 1 you take, then you get the value determinant always 0. Okay, by checking the values the possibility cases are all should be equal to 1, the positive value will get. It should be determinant should be equal to 0 means the total value minus this. Okay, possibility cases we have done all are minus 1, then it is keep it as to 0, then only we will get the positive determinant values. Therefore the positive determinant values total things as to here how many cases these cases are. Okay, then go to the last one. Last question. The number of n by n matrices that can be formed by using the elements 1 comma minus 1, so that the product of the elements, if each row is 1 and each column is minus 1, is dash. The number of n by n square matrices, n by n matrices that can be formed by using the elements 1 and minus 1, so that the product of the elements of each row is must be 1 and each column is must be equal to minus 1. Okay, so let it be the matrix. First we have to write as n by n matrix, that is in the form let A1, A2, A3, so on up to n by n means n elements, and then B1, B2, B3, so on up to means Bn elements, and then goes to from this P1, P2, P3, so on up to how many elements? Pn elements. Then the order of the matrix goes to how much? N by n matrix. So take the values as n rows and n columns. Then the matrix, such matrix is called n by n matrix. In this, the first row always the product of the first row of each row is 1 and each column should be minus 1. So how many places? The each place can be filled with either 1, 1, 1, 1 as this, and each row. And here we can get as to each column the A1, B1, A2, B2, C2, so on up to this minus 1. Then we can get how many submatrices. The first we can take this total part we can get. So first row always has to 1. Product of the value is 1. And first column is also minus 1. Then how many determinant elements we can get here? N minus 1 and cross n minus 1. Okay. Therefore, each place can be filled in two ways. Each place can be filled in two ways, either 1 or minus 1. Here either 1 or minus 1. Here either 1 or minus 1 up to an. Similarly, the product of the first row and first column we can by using the values, then we get the remaining matrix as of order n minus 1 into n minus 1. So total value we can get as 2 to the power of how many? N minus 1 cross n minus 1, that is 2 power n minus 1 whole square. Just now 4 by 4, the previous problem we have learned, that is how many matrices we can get. So here the matrix elements as 3, then we can get as to 3 power 4. In previous matrix, for the matrix 2 by 2 we can get 2 power 4. 2 by 2 means 2 square, 2 of 2 by 2. And then it is goes to the value of the values to n books are there. Uh, so total 2 to the power of n by n. If it is by using the each and every element as 1 and minus 1, 1 and minus 1, how many we will get means 2 to the power of n by n. By applying the product of the elements, each row is 1 and each column is minus 1, then becomes to the order of the matrix as n minus 1 into n minus 1. Therefore, the total number can be number of ways of the matrix is 2 to the power of, we can get. Here n minus 1 is there, so 2 power n minus 1 into n minus 1. 2 power n minus 1 whole square number of matrices we can get. Okay, now observe and think and observe it, then you get the answers. Okay, that is the conceptual questions. And then the proof is remain. The proof is remain in the first. I mean, next write down the sets. If a set containing 8 elements, then the number of ways of forming a subset, the first question, and then the number of subsets containing exactly 3 elements, and the third question, the number of subsets contains 4 elements, and question number 4, at least 6 elements. Question is like this: a set contains 8 elements, then first question, the number of ways of forming a subset, number of ways of forming a subset, so that question number 1, the subset containing exactly 3 elements. Second question, the subset containing exactly 4 elements. Question number 3, at least 6 elements. All the questions is like this. In the basis of sets, a set containing totally 8 elements, the number of ways of forming a subset, so that the subset containing exactly 3 elements, and the subset containing exactly 4 elements, and the subset containing at least 6 elements. Then the number of subsets can be formed, so that first question, the subset containing exactly the elements, like this. So first question solution. So the subset containing exactly out of 8 elements, that is the formula we can get as 2 power n number of subsets, okay. But the subset containing exactly 3 elements, so that is containing exactly 3 elements. For the first question answer, out of 8 elements, we are selecting 3, that is 8C 3 ways, that is 8 into 7 into 6 by 1 into 2 into 3. Then you get 56. 3 to the 6 over 56. For the element of second question, the subsets containing exactly 4 elements, that is 8C4. Then 8 into 7 into 6 into 5 by 1 into 2 into 3 into 4. Then you get the value as 6. And then question number 3, the subset at least contains 6 elements, that is at least 6 elements. It may be either 8C6 or 8C7 or and then 8C8. 8C6 nothing but 8C2, 8 into 7 by 2 into 1, then it will get 28. 8C7 nothing but 8C1, then you get 8C1 nothing but 8. Obviously NCN is equal to 9. So totally 37 elements we can get. And the next one, the fourth question is also is given. Question number 4. Question number 4, that is the subset contains at least the subset contains at least 2 elements, at most 5 elements. So question number 4 solution, that is at least 2 elements, at least 2 elements, at most 5 elements. At least means minimum. At least means minimum 2 elements. At most means maximum. Okay, in our language. Then we get 8C2 minimum, 8C3 and 8C4 and 8C6. Maximum elements having only 5 elements are given. If it is 6 are given, if it is right as to 8C6. But here maximum elements only 5. Then up to this is will be closed. 8C2 just now we have write 28. 8C3 18. 8C3 nothing but 8 into 7 into 6 by 3 into 8 7 is 56. Plus 8C4 nothing but 8C2 8 into 7 by 2 into 1, that is again 20. 35 to the 2 3 4, oh sorry, 8C4 and then it attached to 8C5. Next 8C2 and 8C4 both are same. Sorry, 8C4 8 into 7 into 6 into 5 by 4 3 2 1. Okay, 35 into 2 70. 8C5 nothing but 56. Then total value is 1220. Then so 210. So that is the question. In the similarly, question number 2 in the previous year question, a set contains a set contains 12 elements. Then the number of subsets that can be formed so that question number 1, exactly the set containing exactly 5 elements, exactly 5 elements, at least 8 elements. Question number 3, at least elements, at least 8 elements, at most 12 elements, at least 8 elements, at most 12 elements. Okay, so for the first question solution, exactly 5 elements, exactly 5 elements, so that is equal to 12C5. Okay, so that is 12 into 11 into 10 into 9 into 8 divided by 5 4 3 2 1. Then total cancellation we can get 720 ways. And then go to the second bit, Exactly, at least 8 elements. At least 8 elements. At least, no, no. Question number 2 is given 9 elements. Only 9 elements, set containing 9. So that is, you can write as 12C9. 12C9 nothing but equal to 12C3. NCR equal to NCn minus R. 12 into 11 into 10 by 3 into 2 into 1. Then you get the answer as to 220. Okay, next last one. At most, second one is 9 elements. At least 8 elements. At least 8 elements. Third bit. At least 8 elements. At least 8 elements means it may be 8 or 9 or 10 or 11 or 12. So 8 or 9 or 10 or 11 or 12. Out of 12 elements, we are selecting 8 means 12C8. R means plus 12C9 plus 12C10 plus 12C11 plus 12C12. Then the total value becomes to 12C8, 12C8, 12C8 means 12C4. 12C4 means 12 into 11 into this value. By simplification, total answer is we can get as to 365 the answer. Okay. Next, at least 8 elements, at most 12 elements. It is the same. At least 8 elements means minimum is 8, maximum is equal to 12. The question revised. This question is not given. Erase it. Three questions only. 5 elements, 9 elements. These are the question. Exactly 5 elements means the 12 out of we can select 5, 12C5. Exactly 9 elements means it is also 12C9. At least 8 elements nothing but it can be either 8 selection or of the type 8 or 9 or 10 or 11 or 12. So that means we can write as 8 out of 12 we can get 12C8, 12C9, 12C10, 12C11, 12C12. In the lastly we get the value as 365. Okay, tomorrow I'll explain the remaining problems, Nana. Okay, right, thank you.